All right, so it says, would a fractional answer make sense in this situation? So we kind of stopped in the middle of this. But so I'm going to recap because I was supposed to record the video and I recorded the wrong screen. So there's this whole explanation of this problem that I did yesterday, but it doesn't necessarily have the screen on there. So let's kind of recap. I'm going to kind of go through from the beginning. Yesterday we said that Mari, Carlos, and Amanda collect stamps. Carlos has 5 more than Mari, and Amanda has 3 times as many as Carlos. Well, we don't know how many stamps Mari has, so this is the letter S. So we said Mari equals S. Why did I say that? Because we know nothing about Mari's stamps, and whenever we don't know something, we assign a variable to it. We use S because that stands for stamps. Well, what do we know about Carlos? Well, we know that he has 5 more stamps than Mari. So if Mari has S number stamps, then Carlos has S plus 5. And they said Amanda has 3 times as many as Carlos. Well, Carlos has S plus 5, so we're going to multiply 3 times S plus 5. So then to find out something, they say altogether they have 100 stamps. So I kind of stopped right there. But altogether they have 100 stamps. So to solve this problem, we start saying, okay, Mari has S stamps. That's supposed to be an S. Let me make that look more like an S. I get out my handy dandy tablet. So we're going to say that Mari has S number of stamps. So then Carlos has S plus 5, like we stated earlier, and Amanda has 3 times the quantity S plus 5. Well, if this is Mari's number of stamps, and this is Carlos, and this is Amanda's number of stamps, altogether, they have a total of 100 stamps. So this plus this plus this has to equal 100, mathematically speaking. You guys quit talking and look at the board and write this down. All right. So then what I need to do is I need to go through here step by step and combine like terms. But before I combine like terms, I'm going to distribute this 3 through the parentheses. So 3 times S is 3S. 3 times positive 5 is positive 15. And then I don't need parentheses here because it's just S plus 5 plus 3S plus 15 equals 15. Well, next phase, I'm going to combine like terms. So here I have an S, here I have a plus 1S, and here I have a plus 3S. So if I take 3 S's and I have them in my hand and I add an S and I add an S, how many S's do I have total? 5. So I have 5 S's, and I know my S's look like 5s, and I know my 5s look like S's, but that thing circled in orange is 5S. Then I'm going to do the same thing with the constants. I have a positive 5. Let me change the color so you know what I'm doing. I have a positive 5 here and a positive 15 here. Well, that's easy for you guys to do. That's 15 plus 5 is 20, right? So I get 5S plus 20 equals 100. So now I just solve for S. So when I solve for S, the way that I do that is I need to move this 20 to the other side. Since I'm adding 20 to S up here, I'm going to subtract 20 to move it to the other side. Remember, whatever I do on one side, I do to the other. 20 minus 20 is 0. 0 plus 5S is just 5S. And then 100 minus 20 is 80. Lastly, 5S means 5 times S. To move the 5 away from the S, I do the inverse of multiply, which is division. The reason all these are called properties of inequalities is because I'm doing the same thing on both sides. So whenever you hear Mr. Adams say, whatever you do on one side of the equation, you have to do to the other, that makes it equal. Keeps the equation balanced. So we say S is 16. So Mari is 16. Carlos is 21 because he had 5 more than Mari. So 16 plus 5 is 21. And then Amanda had 3 times the amount that Carlos had. He had 21. 3 times 21 is 63. So she had 63 stamps. To double check our work, we're going to say 16 plus 21 plus 63. Guess what? It equals 100. And that's supposed to. Remember, the combined, they had 100 stamps total. So we did everything right. We got the right answer. So now, it says, would a fractional answer make sense? So in the context of the problem, would we end up with Mari has S equals 5 over 4 or something like that? The answer would be no. You, write this down, you would not have a partial stamp, right? So a fraction is a partial, right? If I have 3/4 of a stamp or 0.7 of a stamp, oh, I should say would not. Ew, that's not good. That'll confuse everybody. Would not have a partial stamp. Not have a partial stamp. It would be a whole number. Remember that? That's how we started this year, talking about a whole number as a counting number. 1, 2, 3, 4, 5. So you wouldn't, that wouldn't be a fraction. Now, technically, you would have, at some point, we had 80 divided by 5, but if you reduce that, it reduces down to 16. All right, so here's another thing to discuss. What might it mean if a check revealed the answer to the real-world problem did not make sense? So that could mean two things. One, what if you get a scenario where you have 120 equals, they're talking about that last step. Well, you made a mistake here. So if you went through and then you did the check at the end and you plugged all the numbers in and added them up, if it didn't equal 100, you just made an honest mistake somewhere. Maybe when you were solving or maybe when you were plugging it in, but you made a mistake. So that's one scenario. Another scenario might be, what if Mari had 80 stamps? What if you forgot to divide by 5? Well, that wouldn't make sense either, because Mari, these are all mistakes, by the way. But when I say made mistake, I'm talking about just a simple math mistake. Added when you should have multiplied, something like that. Divided when you should have subtracted. Mari had 80 stamps. That's too many for Mari to have. So sometimes you'll crank through there and you'll get, or what if Mari, if you did the math and it said Mari had 800 stamps? Well, Mari wouldn't have 800 stamps if they combined had 100 stamps. Does that make sense? So somewhere you made a math mistake. And what causes that? Well, here, more than likely, your issue would be is your equation was wrong. So I always tell students when we're solving these things, do a common sense check. If I say, well, my gym membership is $20 a month, and every time I use the massage chair, that's $1. I use 3 massages, and I went to the gym for a month. What was my bill? And then I do an equation, and then I do the math, and my bill was $2,000. That's not right. Or my bill was $18. That's not right because the minimum fee is $20. But if I wrote the equation wrong and I solved the equation properly, I could get an answer like that. That's more of the second option. The other one is I do all the work and I get 19 equals 23. Well, that's not right either. Somewhere I made a mathematical mistake, probably when I plugged it back in. So that's why you do the problem two ways. If you solve the equation, then plug it back in and it checks out, you probably did everything correctly. Maybe not. But it has to make sense when you're done. Do you guys have any questions? Let's try one more of these problems before we move on to the next thing and see if how we feel about this. So let's consider this rectangular garden that's fenced in on all sides. It has a total of 256 feet. Now, I said total even though it wasn't written down. Now, what they're talking about is this whole thing has a fence around it. So when they say total, they're talking about the length. This is the fence. This little orange box, if I were to disconnect that, that whole thing would be 256 feet, okay, of fencing. Then it says the garden is 8 feet longer than it is wide. Okay, so this is the length, and this is the width. It says find the length and width of the garden. Well, what do we call the fencing? What mathematical term are we talking about when we talk about going around the outside of the rectangle? Perimeter. So the formula of the perimeter is equal to 2 times the length plus 2 times the width. And the reason we say 2 is because rectangles, you have a width and a width that are the same, and a length and a length that are the same. So then what's the length? Well, it's 2 times this stuff because this is the length. So I'm going to say 2 times W plus 8. And what's the width? Well, we don't know, so we just say W. Okay? But actually, do we know the perimeter? Yeah, the perimeter is 256. They told us that, right? So now what I want to do to solve this is I'm going to distribute the 2 through the parentheses. So 2 times W is what? 2W. 2 times a positive 8, and that you really got to think about if that's positive or negative. What is that? Positive 16. Now the reason I'm saying it that way, it helps me get the right sign right here. And then over here I just have plus 2W. And all of that is equal to the perimeter of 256. So now as I look at this, I have a bunch of numbers and a couple of W's. I can make it look like W equals some sort of number. And how do I do that? I'm going to do the inverse. So whatever's being done in the equation, I just need to do the inverse of that. Okay? So I'm going to combine like terms. I have 2 W's and I add another 2 W's in my hand. How many W's do I have total? 4. And then I have plus 16 on the other side. After I've combined like terms, and let's write that down here, what did I do here? I used the distributive property. Here I combined like terms. And whatever I write down, I want you guys to write this down because when you go to do your work, that's going to help you. Remember, even on your test, Mr. Adams is so kind to let you use your notes. Ooh, that's a horrible M. So that means that you could look at this and follow the steps. So we're going to say combine like terms. Okay. And then what do I do to solve? Well, I want to get W by itself so I can move the 4 or the 16. The 4 is always moved last. The number in front of the letter. Do you guys remember the fancy word for the number in front of the letter? Starts with the letter C. Coefficient. So the coefficient is always the last thing we move. So if I'm adding 16, what's the inverse of adding 16? Subtracting 16. Very good. You guys must have an excellent math teacher. So then this becomes 240, and that's equal to 4W. Now 4W means 4 times W. What's the inverse of multiplying by 4? Dividing by 4. And whatever we do on one side, we do to the other. So that means that W, what's 240 divided by 4? 60. A lot. So that's the width. And the length, remember the length was equal to W plus 8. So that would be 60 plus 8, or 68. We could double check that because remember, if that's right, when I add all these sides up, it should equal what? 256, right? So if I say 60 plus 60 plus 68 plus 68, it equals 256, right? So it worked out. It's almost like I know what I'm doing. Well, you guys helped a little bit, if we're honest. Huh? You carried? You did all the heavy lifting? We carried. That's funny. I gotta select this and move this out of the way so you guys can see it a little better. I want to grab this thing and make it smaller. There we go. We'll just put that over there so you guys see that we double checked it. Okay? Any questions on that? Yeah. What's your question?